Example number 7. A ball is thrown upward with a speed of 48 feet per second from the edge of the cliff 432 feet above the ground. Find its height above the ground t seconds later. When does it reach its maximum height? When does it hit the ground? For the motion close to the ground, we may assume that the downward acceleration g is constant, its value being about 9.8 meter per second square or 32 feet per second square. Since this problem, we are using the feet in feet more, so we will use the acceleration is 32 feet per second square. If we assume that the ball go up is positive direction and the ball going down will be negative direction, so S of t will be the distance that the ball travel. V of t is the velocity function, and A of t is the accelerate function. And again, if we assume that the ball going down is a negative direction, then the velocity will be decreasing, and the function A of t acceleration will be negative. So we have A of t is dv over dt, which is negative 32. The problem gives us 32, but the direction is negative because the ball is going down. Now we take the antiderivative to find v of t, which is negative 32t plus c. We need to find the constant c, and we will use the information, this one. So we know that the speed at v0, at the beginning, the speed is 32 times 0 plus c, and that is 48. So that means c is 48. We will plug c in the v of t function. So v of t will be negative 32t plus 48. When does it reach its maximum height? The ball reaches its maximum height when v of t equal to 0. So negative 32 plus 48 equal to 0. And solve for this equation is going to be 1.5 seconds later. So here is the picture. So we have like a cliff like this. Okay, so we have the route like this, right? Okay, so if a ball throw up, but then the ball will moving down so that it will hit the route later. So we can see that at this maximum point, this is the function distance of the ball. And look at the maximum point, we have the slope of the tangent line at that point is 0. Okay, the slope of the distance function is the velocity function, and the velocity function equal to 0 means the slope is 0. So we find t when the velocity is 0 is 1.5 seconds. Now we want to find the distance function s of t, which is the antiderivative of the function v of t. So negative 32 t squared over 2 plus 48t plus d. We will solve for d. Let's simplify this a little bit first. So we have negative 16t squared plus 48t plus d. Okay, we will use this information. A cliff is 42. So from the 0 time, so at the beginning, which is t equal to 0, we're going to plug it in. and the cliff is 432 feet above the ground. So when we plug in 0, the output will be 432. Now it's going to be negative 16 times 0 squared plus 48 times 0 plus d equal 432. Then d is 432. So the distance function will be negative 16t squared plus 48t plus 432. Now we want to find t because the problem asking when, which is finding the time. So we have the distance function. So it hit the route when the distance is 0. Then we will solve for this equation. We will take out the negative 16. Then we will get t squared minus 3t minus 27 equal to 0. Then this is equivalent to t squared minus 3t minus 27 equal to 0. And then we use quadratic formula. The discriminant is 13. Alright, so if we do the minus, it's going to be a negative, and we will eliminate that solution because the time cannot be negative. So we only take the t equal the plus sign. And then use calculator. So this is about 6.9 seconds. That means after 6.9 seconds, the ball will hit the ground.